Hey everyone, let's talk about building and evaluating agents. But before we jump right into it, let's have an agent run in the background real quickly. So one question I have in my mind right now, looking at all of your faces, is how to wake up a crowd using AI. So I'm gonna let that run in the background, and hopefully that wakes you all up too. And as this goes on, we'll see where we can really learn about how this agent is formulated and how we evaluate this agent behind the scenes. But you can already see there's stuff happening. But let's get started. So I'm going to say right now that all of you have probably built some sort of GenAI demo. And you've tried to release it to the world and probably received extreme backlash about how difficult it is to actually have it touch end users. The reason why is the proof. How do you prove that your application works not in your toy laptop setting, but in a setting where hundreds to thousands to tens of thousands of users would use it? And not always in a good way either. Because unfortunately, there are a lot of malicious users out there, or people just don't get how to use the AI-enabled feature that you're building. And then one step further is agents. Those are also easy to demo, but they're harder to productionize than any GenAI application I can think of. If you're using something like a RAG pipeline or a standard chatbot flow, which is more one-directional, then sure, there's a little bit of leeway there to build systems to understand that better. But agents, now that's the Wild West. But everything I'm going to tell you, don't take my word for it. I've worked with a lot of folks across various teams building models, building AI applications, and building agent applications. And so one thing I want to clarify is the reason that this is important is because in the pre-existing world, aka a few years ago, there was this persona of the ML engineer, those who can actually go ahead and build the models that are used for downstream tasks. They were able to spend months, if not years, building data pipelines into GPU-enabled algorithms that really built powerful features. Now, we're in a world where I can go to ChatGPT and say, do that same task in hours, if not minutes. And so we're at a world where the standard software engineer is now AI or ML enabled. And so that changes how we perceive building agentic applications. Software development had a standard streamlined workflow. You wrote code, plug it into your CI, and hope your DevOps person doesn't find you later because you broke everything, or make a revert later on. Now, AI-enabled features, because LLMs are non-deterministic, aka asking the same question to an LLM over and over again gives different responses just by permuting the words you use. It becomes experimental by nature. Every time you run a test that has an AI-enabled feature, it may not always pass. So the linear nature of software development, that contract of what you're saying your code will do, is inherently broken and lossy. And so now we had to change what your IP actually is. Before, your IP used to be the code itself. You committed code to the repo, which then packages and releases to the world. Now, the IP is no longer that growing code base that you have of multiple services interacting with each other. It's what you learned in your process of developing that AI-enabled feature. When your boss asks you, did that feature work? You can't simply go to a repo and say, yeah, it did. Because the code that actually calls the LLM won't always give that same response. And so you need to prove via collection of experiments where there's insight to be gleaned from that the actual product you're building is something that is trustworthy. I'm going to skip the slide. And so that, as a result, opens up a collection of new paradigms that exist. At the lowest level, all of us, hopefully, at this point, are good enough prompt engineers. Raise your hand if you use ChatGPT, Claude, Gemini, AI mode on Google. I should be seeing more hands is what I see right now. If you aren't, go to Google later and use AI mode. It'll change your life. Next, when you start to then go from prompt engineering where you have the initial aha that, wait a second, LLMs are useful, they can do things, then you can start to build the software around it. So naturally, the next thing you want to do is, these LLMs don't have all the data I need to answer questions. So then you build RAG, essentially search connecting with your LLM. And then later on, you realize you just want more behavior from your large language model in the first place. So you start to look at things like reinforcement learning or fine-tuning on top of your model. So you can start and increase the behavior of the model behind your agent in the first place. And then you have a strong model, and now the capability to do agentic things. So then you build agents from these powerful fine-tuned model. And at the end of all of this, you're building your own service that's an agentic application that can start to do a collection of useful tasks. And so there's a whole new process around how to build applications. This screen is scary for many of you, and maybe really exciting for the other half of you. This is what the foundational model builders and machine learning engineers building those great models that are powering ChatGPT and such are looking at. These prove the metrics that that model is actually utilizing the data being thrown at that model architecture. But that doesn't mean it's going to work well for your AI application. So that's when we start to think about this new paradigm right here of system engineering. That's what I call those building those AI applications on top of these powerful models. And so before we jump ahead, I want to put a stake in the ground and give you a formalized definition of an AI agent. It's contentious, it's kind of scary, you're gonna say this out in the world and someone's gonna attack you. They're not. But AI agents, to give that formal definition, are autonomous AI systems, so they're self-thinking, that plan and execute multi-step tasks in a loop, so they're gonna keep thinking and doing actions until it gets closer, using memory and tools, so saving the conversation state and accessing an external environment using tools such as Google or Zapier and such until a goal is achieved. So to reiterate, autonomous, able to plan using memories and tools for goal orientation. Your agent wants to solve a vague task by doing intrinsically multiple tasks via the tools it has accessible to itself. And that's very different from so to reiterate what that looks like visually is in a standard LLM workflow, AKA chain, for those popularized by the LangChain package, is a single DAG. You have a specific task, you have your LLM that you want to do, and you have a sequence of steps that you predefined that may talk to an LLM multiple times to solve that one task. And so that's a little bit easier to manage. The agent world is that autonomous nature. So you can see here it's inherently a loop where an LLM is always going to consider using what tools or memory state to continuously ask itself, am I getting to what this user wants me to do? So for instance, a chain could be answer this specific question. If you ask it to answer it from a different resource or look up external data, it's going to fail. It doesn't have access to that. You didn't build it in. But for an agent, I can willy-nilly give it a bunch of tools on my MCP server or wherever you're hosting your tools and say, use any collection of these tools to solve this vague task that may come in. You can form fit your agent to solve a variety of tasks, but in the day, those agents you're building have that autonomy. That is what really makes it appealing for all of us right now. I already reiterated this, but this is a good picture people like to take of those key characteristics for those agents that I mentioned. And I really like this pattern of how to think about one version of an agent loop. This is specifically the React pattern. And so this pattern is really useful for understanding how agents are actually being able to go ahead and create this loop until it finds that final answer. And so in essence, I ask that question, how to wake up an audience using AI. The LLM now has to spend a second creating a plan to execute. It realizes that it can go ahead and take one step closer to finishing up that plan by using tools or looking at understanding what's already saved in its mind via the memory. It reobserves what the output of that step was and thinks, did I actually solve the task or do I need to do some more work? And you keep reiterating this cycle over and over until you explicitly get a signal that says, hey, I'm done. And what that can look like is a phrase that says, hey, I'm done. Whatever signal you want is what you can build in to this agent loop. I'm going to skip this because it actually hurts my eyes, so I do apologize. And so inherently, this also opens up this crazy concept of, well, if my one agent can do this autonomous thinking and has an output, can I also chain together agents? Can I create an agent of agents? And the answer, unfortunately, is yes, to my chagrin. And so it's really powerful that you're able to have a variety of agents that are all able to do very specific tasks that communicate to each other. But Anish, why not just have one super agent that just does everything? Is a natural question I usually get. So I'll just answer that right now. If you have one agent with 250 tools, 70 different tasks it can solve, and 300 different users all wanting different things from this agent, and that agent fails at all of them because it's calling the wrong tools constantly, it's having weird thought processes like me early in the morning, then what we see here is that that agent is actually doing nothing for you. So a good agent system intrinsically, even though it is autonomous, these agents, has a core purpose that you're building that agent for. And once you have that core purpose down, you then expand out what other behaviors you want from your agentic application. And so what that looks like is adding more agents or more systems around that agent that can help it gather that information so it's always consistently correct. Because good agents are consistent. And so like in this example where we're actually doing the deep research style of multi-agent system, we have a researcher agent who's good at, as the name implies, researching. Then we have an insights agent, a content writer agent, and then maybe like an editor agent to be a little more generalized to build out this final blog post. All of them in isolation have their own set of tools. They also understand this inherent contract of what information goes from agent to agent. So multi-agent systems are only as strong as your strongest agent. If you're the weakest, it's only as strong as your weakest agent. If your weak agent fails somewhere in this process, every other agent before and after has lost information. It's going to get bad information downstream and it's going to waste good information from upstream. So every agent must be strong to build strong multi-agent systems and agentic applications. Here are some patterns that people like to take a picture of. I will not expand on this at all. So feel free to ask me questions later. But there are a lot of interesting paradigms, though, to make multi-agent systems a little bit more tractable and easy to manage. And also, I also wanted to say, agents are exciting. They're super fun. And we think it can do everything right now. It can't. But these are three things agents have been proven to be extremely successful at. Coding, deep research, and customer support. Coding, because teams like Cursor and the teams at OpenAI are shoving a lot of great code at these models that are powering these agents behind the scenes. So these agents are still only as strong as a good LLM. And I will say LLMs are really good at coding right now. But don't use it autonomously for all of your code. Like don't just push commits from agents from your coding world. Your PR lead or your tech lead will be extremely upset at you. Deep research is also a very powerful use case for agents due to the capability of agents being good at using tools for gathering information and then using that information to come with insight. In fact, if you ever copy and pasted anything into ChatGPT and said summarize it, that's inherently what these deep research agents are doing, but finding those documents that you're pasting in for you. And then from a practical business perspective, customer support is also a very powerful one for the same reason as deep research. The only difference being that the knowledge base available to a customer support agent is your proprietary information. Most customer support folks are looking to your internal knowledge base and FAQs to solve user questions. So why can't an agent also? And I really like this framing of how to think about agents. The only thing that made internet useful was the general populace's ability to access websites, which is where the internet was inherently hosted. Similarly, smartphones were useful once we had apps, no matter how dumb those apps were in our youth. And then lastly, I will say that the current mechanism to touch all of the advancements in the AI world are going to be agents. Agents will have very specific behavior via tools that allows it to access all the behavior that we as humans are naturally doing. It's going to do so in the same environments that we're doing, so they're going to search Google or search your database, similar as you would do if you typed in a query in Google or used an SQL query for a database. And it's going to be as accessible as a chat interface is that we're all getting used to as a modality of interaction with information we want from these LLMs. And so agents, I will say, are going to be the apps of the AI world. And the way you're going to be building these agent workflows is using a collection of horizontal frameworks. There's actually a hidden fourth one, which I'll say out loud, but you may be using something like a lang graph or a lang chain once you start to ideate on what types of agent systems you want to build. Maybe you want to be more research focused and use a tool like AutoGen, which allows you to build something like a simulated environment for your agents to live in. So an example of a really interesting paper is someone made a fake pallet town for my Pokemon friends and had a bunch of fake humans interact in that town. AutoGen was the framework that allowed that to work. Or one package that is very near and dear to me, which I heavily use a lot, is CrewAI. That has a lot of abstractions to allow you to really build that specificity into the agent behavior that you want. So that's to say that there's going to be a horizontal way frameworks that exist as agents become more mature and opinions are created about how we should be building these agents. But there's also a vertical framework that exists too. Agents being built by people in the finance world or the healthcare world who are going ahead and building that agent behavior that they want you to plug in to your software. You're not building the agent, you're using the agent. And so there are vertical frameworks, I would say, to think about too. So you don't always have to build your own agents for your company. Now you can utilize agents in your programmatic settings. And then also there's that hidden fourth horizontal framework, which is called your own two hands, typing and creating your own agent framework. I actually recommend that as an exercise for folks who are interested. It's actually not that hard to build your own agent framework. It's as simple as a fancy for loop and using structured outputs with your LLM provider. And so, cool, I mentioned all these reasons. We talked about definitions of agents. We talked about why agents are useful. Why are agents easy to demo but hard to productionize? It seems straightforward. It's as simple as releasing a chatbot, isn't it? Well, agents are prone to mistakes a human wouldn't make. They're non-deterministic and inconsistent. And because they're much more complex, AKA you have to unfurl the thought process of an agent to really find where that failure came from the final output of an agent. That complexity makes it much more difficult to gain that visibility, especially due to the autonomous nature of agents. That's one error that you found from that agent may never be found until 30 times later when it happens to a business critical use case by a downstream customer that you do not want to lose a deal to. So now here's the crux of this. How do we continuously evaluate and improve our agents? I will not share the slide. Go talk to us at the booth. This is architecture. So let's go back to that deep research agent that we had running in the background. You can see here that, let's actually see what it says. Oh, sorry, scroll this. Wow, it's longer than I thought it was gonna be. So I'm going to super quickly read this and say that this is not a great answer. It says, go and write an article for all of you right now and have you guys consume that. I will not be doing that, so I would give this a thumbs down, for instance. This is like a natural interface you can imagine for these chatbot style applications. That's cool and all. So we have this deep research agent, which has a bunch of complex behavior, which I can explain in the booth if you want to see me later. But in essence, there's a lot of agents talking to each other, and they're all doing individual types of tool calls to actually come to an aggregation of information to answer the question that was asked. So I saw that output is bad. How do I know that's consistently bad? Well, the first thing you want to do is monitor experimentation. So the tools that I recommend here are tracing, debugging, governance, and testing out a bunch of prompts via different model providers. And so I'm not going to show screenshots. Let's just keep this live a bit, keep it exciting. So over here is the Weave UI that we offer at Weights and Biases. So the first screen that you're going to see here is the qualitative analysis of these agentic style applications. So you see this down thumb over here is actually just the question I asked. If I jump over and open this side panel, which is this trace view, don't worry, it's not as scary as it seems. You can see there's a lot of information available here. The one that's interesting is that we have the query I use, so how to wake up a crowd using AI. I know what model provider I use. And I have access to all the details in that thought process from that agent. I see what search terms it used, what pages it searched up on Wikipedia, and what images it actually used a vision language model to look over. And we can see here that we can see the final output right here also in this report. If we were to read this, it would go and give us that same text that was rendered in that UI. Let's see, if I can actually render this myself. I forget if there's HTML Markdown. Yes, so if I turn this Markdown mode, you can go and see that same output that we see here. So this is useful for the initial I/O interaction. For my given inputs, did I get the proper outputs? From this, it did its job, but it didn't do a good job. So that's where I can see I added in that down thumb. If I actually want to investigate where that failure could occur, there's a lot of tools available here. Just what is useful to investigate as someone who wants to optimize these agents is you want to jump all the way down to the raw chat interactions between the agent and the LLM provider. We may want to go through and see what every tool call is doing to each next step of the thought process of that agent. You may want to investigate individual calls to a tool itself. So for instance, a summarized page call, and see if there's any faulty, any errors that occur from a logic perspective, and not like a X it didn't run, but more so, did it actually summarize properly? Or I may actually want to see things such as the latency. Was a certain particular step taking too long because it was stuck in an improper thought loop or what now? So a mixture of trace views and flame graphs are really useful for understanding the efficacy of the model in terms of latency, and these trace views are useful for understanding where those thought process failure modes are coming from and the cost of that failure mode in both time and monetary value. And so that's how you can do some of this qualitative analysis for agent optimization. Just skip through some stuff. Maybe this is a useful slide for some folks, but yeah, that's fine. Then so the next step you want to do is, after qualitatively analyzing your agentic application, you then want to say, prove over not just those 10 examples that you manually checked. You want to run 1,000 examples, 2,000 examples over your agentic application and be able to say with certainty that it's consistently at least doing a job to some degree of accuracy. And so the important natural question is, well, what does accuracy look like for an agent? And so there's kind of like 3 methods of doing this. One is eyeballing, which we talked about. But the other 2 are manual evaluation and LLM eval LLM. Manual evaluation in this case is building strict unit-style tests that represent behavior you want from your agent. Let's say my agent is always supposed to render Markdown. Well, then go build a Markdown test and have that pass-fail, for instance. And then you can quantify how frequent is actually going ahead and doing that Markdown generation. LLM eval LLM, I'm just going to call it LLM Judge. And LLM Judge is another useful tool where you go ahead and create a rubric in which you can ask a separate LLM to look at the responses or thought process of your agent and come up with some numbers that represent failure or not. And then also similarly under manual evaluation, you can go ahead and just pull some eval harnesses or create your own numeric quantifiable metrics that represent success for your agent application. And unfortunately, I can't just give you one specific metric that proves that. All of these metrics are always based on your proprietary use case. There's some out-of-the-box ones you can look at, such as, does it sound human? Is it using proper punctuations? Is the grammar appropriate, et cetera? But when it comes down to, is the agent working for your business? Well, you should sit down, understand, what is your business looking for this agent? Is it a CSAT score? Is it some sort of consistency of what outputs it comes out, if it's like a recommendation of a certain product, if it's like a recommendation-based agent, or in the case of our deep research agent, is it actually properly summarizing the information in a way that most of the output is utilizing most of the pages is searched up. Regardless, you'll usually see that the end result of whatever data set that you're aggregating to run these scoring mechanisms that you're creating over looks something like this. Question, context, answer. So we're stealing that from the RAG world, but also answer type and tool list. The reason I particularly add answer type and tool list is that there's this crazy concept, so this slide is a bit scary, called agent trajectories. The thought process of an agent in itself is a unit of evaluation that you can observe. So what I mean by that is that the sequence of steps to come to your answer in itself is another layer of optimization for an agent. Agent trajectories are scary and hard to actually optimize at this point. And so there are a lot of techniques that are trying to be made that look at this specific problem statement. The reason just looking at the inputs and outputs of an agent aren't enough is because for that same input for that agent, it may go off on a completely crazy tangent of thought to come to a solution. And so agent trajectories are my current research obsession. And so I think it's something that all of us should consider when building agent applications. Simply looking at this question answer will lead to a lot of improperly optimized agents, which I have seen in the wild, where you think it's actually doing the correct thing because the output looks proper, but it's actually thinking extremely improperly, taking too long as a result, and costing you a lot more money than you need to be. And so from our side, let's say what we can do is actually go and take these traces we have here, so those thought processes and those inputs and outputs, build data sets that represent the core problems we're trying to solve here. So in this case, we're only going to be looking at input and output to keep things a bit simple. Generating a collection of measures that represent success for us. So in this case, we're going to keep it a bit simple. We're just going to have a pass, fail, or relevancy. We're going to tie it to a specific version of our agent that we want to try out. In this case, I swapped out GPT 4.0 with GPT 4.0 mini. And then I combine them all together, stir the pot this Halloween, and then create this nice little eval dashboard that we see here. So these are the ways you can then say, across various dimensions of success for my agent, here's what my slight adjustment, so the change in the model, does for my accuracy measures. So in this case, you can go ahead and say, with Definity, that research agent V76, which used GPT 4.1 mini as opposed to 4.1, across the board had better measures, except it did take longer and took more tokens. So the natural balance play occurs of, was that accuracy improvement worth the additional latency and cost? And that's for you to determine with your business. And so, the next natural step you'd want to do is then take this, now you have this workflow made. You have this qualitative analysis, this quantitative analysis, data sets that represent a good agent behavior, a streamlined way of changing portions of your agents itself, and then also the scoring mechanisms, which you can definitively come back to and say to your boss, this is what defines success for each of our agent versions. And just keep doing that process over and over again, where you deploy to production, look at dashboards, live dashboards and live monitors to prove that your agent's doing a good job, adding in feedback and mechanisms where you can. And then continuously co-improving that agent by using those evals and assets I mentioned. And so, at the end of the day, improving agents is more about doing the science, the experimental approach I mentioned, and not the fiction. So come down to the booth and we can speak to you more about agents in general and the different offerings we can help you with. And if you want to get started, it's as simple as adding 3 lines of code to build all those dashboards I just showed you. And if you want to talk to me more, I have a mini course on agents for free online, and we can help you ourselves by showing you really how customers of ours go ahead and build agents. So all I have to say left is happy building and enjoy your lunch.